All right, guys, Mr. Antonucci here, and in this video, I want to teach you how to find the greatest common factor, otherwise known as the GCF. First thing we got to talk about is how to find the prime factorization of a number. We're going to use the method called what's called a factor tree, and the prime factorization is when you break a number down into and rewrite it as a multiplication of its prime factors. So you could just take two branches off of 144 and think, what two numbers multiply to 144? Well, 12 and 12 do. There's multiple other ways to get started here, but when you do the factor tree at the end, you should get the same factors no matter which way you start if you do it right during the steps. Then you break the 12s down if you can. 12 is 4 times 3, and then 4 times 3. 4 is 2 times 2. 3 is prime. And this 4 is 2 times 2. So when you get to the end of the branch, you should have a prime number. 2, 2, 3, 2, 2, 3. So the prime factorization of 144 is 2 times 2 times 2 times 2 times 3 times 3. If you pump all that multiplication problem into a calculator, you will get 144. Okay, so that's going to help us when we now find the greatest common factor. Let's start off with one that's pretty straightforward, 30 and 75. 30 is 2 times 15, and 15 is 3 times 5. So the prime factorization of 30 is, I like to circle the ends of the branches when you get to a prime number, 2 times, actually, let me write it down here. 30 is 2 times 3 times 5. 75, multiple ways you could do that, but I know 75 cents is 3/4, so 3 times 25, and then 25 is 5 times 5. Again, we'll circle the ends here. So 75 is 3 times 5 times 5. Now, the greatest common factor you want to focus on the word common. You look at all the common factors of each number. They both contain a factor of 3, and they both contain one factor of 5. So the GCF is going to be 3 times 5, or 15. So 15 is the GCF of 30 and 75. What that means, that's the largest number that divides evenly into both 30 and 75. Okay, now as a sidebar, if you do this and they have no common factors, that means the two numbers are what we would call relatively prime. The numbers themselves may not be prime, but they don't contain any common factors. All right, let's do one more example that's a little bit more difficult and also contains variables. You do the same thing. You start off by doing the factor tree. 64 is 8 times 8. 8 is 4 times 2. 4 times 2 here. And then 4 is 2 times 2. This 4 is 2 times 2. So you get 1, 2, 3, 4, 5, 6 factors of 2. So 64 is 2 times 2 times 2 times 2 times 2 times 2. And then you have the x squared. X squared means x times x times another factor of y. Now 36, multiple ways you could do this one. You could start off with 3 times 12 or 4 times 9. I'm going to start off with 6 times 6. And then that would be 2 times 3. And this would be 2 times 3. And those are all prime. So the prime factorization of 36 is 2 times 2 times 3 times 3 times x, 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 y. Now what you want to do is circle the common factors of everything. So they both contain a factor of 2 and another factor of 2. They don't have any more common factors of 2. There are no common factors of 3. And they each contain a common factor of x. So the GCF is 2 times 2 times x, which is 4x squared. So that is the largest factor that will evenly divide into both 64x squared z and 36x cubed y. All right, so hope that was helpful to you in finding the greatest common factor.